Hello, algebra students. Mr. Lawrence here, and before we jump into the next unit, we are going to review a couple things that you're having a little trouble with. The midterm made it plainly obvious. Eighth period in particular, you had extreme trouble solving quadratic equations. You tried to do them like they were linear equations. Many people in second period understand this concept, but not enough of them for me to move on. So we are going to talk quickly about linear and quadratic equations and solving them, and we'll get a little extra practice before we move on to the next unit. And we have got a couple extra days here, so that'll be a good thing. Remember, to tell if a linear equation is linear, its highest exponent needs to be 1. Okay? It's quadratic, the highest power is 2. Okay, so, and usually we don't write the 1, so the linear equation is assumed to be there. So we are going to, the 1 is assumed to be there in a linear equation. Sorry, I didn't say that very well. All right, so for example, number 1, we're going to add 5 to both sides, right? Because we listened to Saddam. So 3x will equal 18. And then to get x alone, we're going to divide by 3, and x is going to equal 6. And there's our solution. But on this one here, the quadratic one, we can't do that. Why? Because in a quadratic equation, it must equal 0. Now, some of you are thinking, Mr. Lawrence, I could subtract 4. Well, you could because this is a quadratic binomial. But normally, quadratic, we want it to equal 0, and then we're going to factor it. Okay, so I'm going to do all my problems like that, all my quadratics, because I'm afraid too many of you just aren't understanding that concept. So I'm not even going to demonstrate the other way to do it. Once you have a thorough grasp of it. Oh, by the way, these cancel out, but they're not gone. It's 0, right? You need the 0 there. Now that it's x squared minus 4 equals 0, okay, so now I'm going to factor, and I have a perfect square minus a perfect square. So that'll factor as x plus 2 times the quantity of x minus 2 equals 0. Now each one of these parts is linear, so I'll solve them individually. I'll go x plus 2 equals 0, and I'll subtract 2 from each side. And so then x equals negative 2, and then I got to go x equals, or excuse me, x minus 2 equals 0. Okay, and then I'll add 2 to both sides, lost my equal sign, and then x will equal 2. So my solution is x equals 2 or negative 2. Okay, so problem number 2 on the left, it's linear. So I'm going to listen to Saddam. To get rid of that 3, I'm going to subtract 3. And I'll get a negative 2x equals 4. And I'll divide by negative 2. And then x will equal negative 2, right? But over here, I want it to equal 0. So I'm going to subtract 5 from both sides. I get x squared minus 10x plus 25. Those cancel, but remember, they equal 0. Okay, well now I have a perfect square trinomial. How do I know? Well, that's a perfect square. That's a perfect square. X times 5 is 5x, doubled is 10x. It'll factor as x minus 5 times the quantity of x minus 5 equals 0. Now each one of these parts is linear, but they're identical, so I only have to solve one of them. And I'll add 5 to both sides, and I'll end up with x equals 5. Okay, moving right along. All right, let's see here. So I'm going to subtract 3 from both sides, and x over 6 is going to equal 2. I'm going to multiply both sides by 6 over 1, and we're going to get x equals 12. But on this one, we need it to equal 0. Why? Because it's quadratic. So I'll get 3x squared minus x minus 2, and that equals 0. And now this is a trinomial. It doesn't fit any of our special patterns. So I'm going to multiply 3 times 2 and get 6. I'm going to list the factors of 6. And I need 2 factors of 6 that subtract to get -1. How about 2 minus 3? So I'll rewrite this as 3x squared, and I'll put a -3x plus a 2x minus 2 equals 0. I chose to write the 3 first. It's supposed to be a -3, so I made it negative. Now I can go ahead and group like this. Grab that plus sign, stick a plus between. Looks like my GCF will be a 3x, and I'll be left with x minus 1. Here it'll be a 2. I'll be left with an x minus 1. I'm going to GCF one more time, pull out the x minus 1, and I'll get a 3x plus 2. That'll equal 0. Now, both parts are linear, so I will solve them. X minus 1 equals 0, and 3x plus 2 equals 0. I'll add 1 to both sides, and I'll get x equals 1. Here I'll subtract 2 from both sides, and I'll get 3x equals -2. I'll divide by 3, and I'll get x equals -2 thirds. Okay? All right, hold on one second. Okay, why don't you try these two problems on your own, see what you can do with them. This one here is an 8, by the way. Let me write that a little bit better there for you. There you go, that's an 8. Solve those, and then unpause the video and watch for my solutions. Okay, you should be paused. If you paused, Leah, did you pause the video and try these? Okay, here we go. Here's my solution. First one, this one is quadratic, so I'm going to subtract 8 from both sides to make it equal 0. And so when I do that, I'm going to get a 6x squared minus a 13x minus 5. That'll equal 0. Multiply 6 times 5 and get 30. And I'll need 2 factors of 30 to subtract to get 13. I'm thinking -13. I'm thinking 2 and 5 work. 2 and 15 work, and 2 minus 15 is -30. So I'm going to rewrite this as 6x squared plus 2x minus 15x minus 5. That equals 0. And then I'm going to group. Okay. Always grab the sign. Grab it. Grab that sign. All right, I'm going to pull out a 2x. I'll be left with a 3x plus a 1. And I'll pull out a -5. And I'll be left with a 3x plus a 1. One more GCF to do. Pull out the 3x plus 1. And 2x minus 5. And that'll equal 0. I'll solve 3x plus 1 equals 0. Or 2x minus 5 equals 0. So I will subtract 1 from both sides. 3x equals -1. Divide by 3. X equals -1/3. That's one possible answer. Or I'll add 5 to both sides. I'll get 2x equals 5. Divide by 2. X would equal 5/2, or 2.5. That's actually, I should have done this. Circle the whole thing as my answer. All right, problem B is linear. So to get rid of the 4, I'm just going to subtract 4 from both sides. In doing so, I will get -x/2, and that'll equal 5. Multiply this side by -2/1. Multiply by -2, and I'll get x equal to -10. And there you go. Problems A and B are not related to each other. They are two completely different problems. So we're going to get some practice in class with this, identifying if it's quadratic or linear, and then solving it. All right, Mr. Lord signing off. Have a good night, everybody.